So, a review of the exponent rules we've had. The product of powers rule says that if we're multiplying, we can add the exponents if they have the same base. The quotient of powers, again, if they have the same base, and dividing, we can subtract. These two require that you have the same base. The powers of powers rule doesn't change the base, but there doesn't have to be multiple bases to do it, and that says you're multiplying the exponents when they're on top of each other. And the power of product rule says if everything inside the parentheses is multiplied or divided, you can distribute the exponent into it. Please note that it's very tempting to try to do this, to try to say that this is 5 to the x. It's not. Those are totally separate, and this cannot be simplified. This, there are two copies of 3 to the x. So what we can say, this is two copies of 3 to the x. That's allowed. And then this, it's very tempting to try to distribute it in and get but it's not x squared plus y squared. This is going to be x plus y times x plus y, which is not the same thing as x squared plus y squared. Okay, so what I recommend we do is we start from the numbers. So 2, 3, and 4. 2 times 3 is 6 divided by 4. Now all the u's, u to the negative 4 minus 3 is, well, I can write it out, minus negative 3. And this is v to the 0 minus 3. So 6 divided by 4 can be simplified as 3 over 2. And then negative 4 minus negative 3 is negative 1. And this is negative 3, leaving us with 3 over 2u v cubed. So what rules did I use? This rule was the quotient of powers. This rule was the quotient of powers. And then going from here to here was our integer exponent rules. Here I'm going to use the powers of products as well as the powers of powers. So this gets multiplied into each of those because these are all multiplied inside. So y to the 9th, x to the negative 6th, y to the 0th. These can be added. So we get x to the negative 6th, y to the 9th, because these were multiplied together. This is the product of powers rule. And now this is a negative exponent, so it can go in the denominator with a positive exponent instead. So that's our answer. Here, we have 2. The x to the negative 1st, we can put in the denominator. Y to the 0th does not change anything. This is 2 to the negative 1st, y to the positive 3rd. So the 2 to the negative 1st is going to go in the numerator. 2 times 2, xy cubed, and 2 times 2 we know is 4. So here we used the power of powers and power of products, as well as the division, the quotient of powers rule. Here, let's just distribute in that 4 into the 2, so 2 to the 4th and x cubed to the 4th. 2x to the negative 4th over 2y squared times 2 to the 4th x to the 12th. Let me not write that as 2 to the 4th. It's much easier to write that as what the actual number is. 2 divided by 2 is 1, so we're going to be left with a 16 in the denominator. If we look at the exponents of x, we have x to the negative 4th and x to the 12th. So we'll have x to the negative 4 minus 12. And y squared, there's no other y, so that stays in the denominator. Well, when we do negative 4 minus 12, that's negative 16. So this is x to the negative 16 over 16y squared, which is the same thing as 1 over 16 x to the 16th y squared. Thank you.